we're checking out how water flows. So the major ways that water moves over, on, and under the Earth's surface. So over, we're looking at clouds and precipitation. That's over the Earth's surface, right? It doesn't touch the Earth's surface in clouds until the precipitation reaches the Earth. So on your little table where it says over, you're going to write clouds and precipitation. Glaciers are on the Earth's surface. Glaciers transport sediment and carve the landscape. So it's moving water in its solid form. This is on the Earth's surface. Also on the Earth's surface is flowing water. Flowing water carries sediment and is the most important sculpting agent on the Earth. So rivers carve huge canyons. They smooth out huge boulders. They break rocks into tiny bits of sand and mud. Flowing water is a tremendous agent of erosion, and that's on the surface of the Earth. Oceans are also on the surface of the Earth. Okay, they're in constant motion. Upper parts of the ocean are constantly moving with currents and with waves that erode and shape coastlines. So again, oceans are on the surface and they are shaping the coastlines. Ocean currents, also on the surface, are very important for regulating temperature on the planet. So they circulate hot water and cold water and nutrients with that water all over the globe. Lakes are also on the surface. Water accumulates in lakes, also in rivers. When it accumulates and it settles in some place like a lake where it's not moving very fast, it can also seep into the ground. So that's where we're getting groundwater. Water on the surface can sink into the ground and accumulate as groundwater. So this is our first example of water under the surface. Any water under the surface is going to be groundwater, and groundwater can emerge back to the surface as springs as well. Some other ways the atmosphere affects the Earth's surface. So if we take a look at this image, you've got the image on the upper right hand of your note sheet, and you've got a similar corresponding image on the bottom here. So some ways the atmosphere affects the Earth's surface. First, we've got water vapor. The atmosphere includes a low percentage of water vapor, most of which is evaporated from the Earth's oceans. We have precipitation. Precipitation includes rain, snow, and hail, and it may fall from clouds and back to the surface. We have wind. Uneven heating of the Earth's atmosphere and other effects cause wind. Okay, so circulating air. Evaporation. Liquid water on the surface can evaporate and become water vapor in the atmosphere. And again, most evaporation occurs over the ocean because that's got the largest surface area of any water on our planet. Our planet is mostly water, 70% water, and most of that is in the oceans. So that's where evaporation is happening. The land and sea absorb heat from the sun. Okay, so in the case of the sea, that heat gets transferred and circulated around through convecting currents, or it can lead to evaporation. In the case of the land, that can either cause transpiration or soil evaporation. So transpiration is kind of like sweating in plants, and soil evaporation is where you actually have water evaporating out of the soil. So you're drying out the land. All right, another aspect of the atmosphere is it blocks some light and UV. So light from the sun passes through the atmosphere, and along the way it can be absorbed in the air, it can bounce off of clouds, it can bounce off of the surface, and it can be converted to infrared. So that's this last one here. Energy is converted to infrared. Energy from the sun. That takes us to this last image here. And so what we're looking at here is the hydrologic cycle. We're going to start with the sun. The upper left-hand corner, the most important part of the hydrologic cycle. If we remove the sun, we have none of this. There's no heat to trigger evaporation. There'd be no rain. There'd be no wind, circulating of currents, nothing. So the upper left-hand corner, the sun or solar radiation, is our number one important thing. Okay, right next to it, we are getting condensation. Okay, so just to the right, the box that's in that light gray cloud, we're going to put condensation. So water vapor starts to come together and condense into droplets. Okay, as that moves over, so we're following the arrows over to the right, the dark gray clouds, once it continues to condense and cool, then we can get precipitation. So the box that's just at the top of the mountain there is precipitation. We've got water falling from the clouds down to the earth. The box just below precipitation, where the rivers are on the side, we're looking at runoff here. R-U-N-O-F-F, runoff. Water running along the surface. So this is streams, lakes, streams or rivers. Okay, below that we have a lake, and the box below the lake we're going to write infiltration. So water from the lake is soaking down into the ground. That's infiltration. And the next box over on the left, we're going to write transpiration / soil evaporation. Transpiration is Transpiration. Transpiration. That's water vapor given off by plants. And soil evaporation. So that's loss of water from the soil to the environment, to the atmosphere. And the box in between transpiration / soil evaporation and the sun, that is evaporation. So this is just surface water turning into water vapor rising up into the system. So again, if we take the sun out of this picture, the whole cycle gets broken. So what role does sunlight play in the hydrologic cycle? Getting back to your notes packet. What role does sunlight play in the hydrologic cycle? It triggers evaporation, which fuels the whole cycle. Okay, sunlight triggers evaporation, which fuels the entire cycle. So if I asked you what the hydrologic cycle would look like without the sun, hopefully you'd be able to tell me it would not exist, because there would be nothing to get that engine started. Okay, Earth's place in the solar system. List the members of the solar system from the sun outward to Pluto. So Pluto's not technically a planet, but we're going to include it in here just for fun. Who doesn't like Pluto? But again, technically, not a planet. It is a planetoid. It's too small, and its orbit is not the same, so Pluto doesn't count as a planet, but we'll still include it here. So starting at the Sun generates its own light. All planets are bright because they reflect the Sun's light. So we rely entirely on the Sun, not just for the hydrologic cycle, but for photosynthesis in plants, for heat, just for livable conditions. Life would not exist the way it is if our Sun was not exactly the way it is. Okay, the next planet, or rather the first planet in from the Sun, is Mercury. Mercury is hot, but it almost has no atmosphere. The next one in is Venus. Venus is also hot, but it has a thick atmosphere that causes a greenhouse effect. Then that's us, the third rock from the Sun. The Earth has water, clouds, and life. Lucky us. And this image here has also included the Moon. Alright, the next one in is Mars. Mars is smaller than Earth and may have once contained liquid water. All sorts of fun studies going on to try and find and prove water on Mars right now, because there is a very strong link between life and water on our planet. So why not somewhere else? If you're interested in that, do some searching on astrobiology and Mars. Lots of fun. So next in are the asteroids in the asteroid belt. Asteroids are fragments left over from formation of the solar system. They're now concentrated in an orbit between Mars and Jupiter. So this is the asteroid belt. This divides the rocky inner planets, the smaller rocky inner planets, from the larger gassy planets on the outer solar system. So the gas giants. The first of those is Jupiter. It's the largest planet in the solar system. It's composed mostly of hydrogen and helium, much like the Sun. The next one is Saturn. It's a lot like Jupiter, and it has rings. It's composed mostly of small chunks of ice. Uranus and Neptune are both bluish-green because they contain methane. And if you've ever been near a feedlot or any sort of cow farm or ranch, you are well acquainted with the smell of methane, so I don't imagine they'd be good places to visit, but beautiful color. And then the last one is Pluto. Again, it's been reclassified as a dwarf planet. There are other objects like it that are further out, so Pluto doesn't count anymore, but that's all right. So orbits of Earth and other planets are nearly circular, so distance from the Sun does not cause Earth seasons. It's not about distance, it's about how the Earth is tilting toward or away. Okay, so those are the members of the solar system. Again, Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto. So if you need a little mnemonic to remember that, the one my 4th grade teacher gave me was, "My very excellent mother just served us 9 pizzas." And it has stayed with me through many years, so it's a very helpful one. The next question, explain why the Sun and Moon are the most important objects to the Earth. So we've already talked about the Sun. We need it for heat. We need it for the hydrologic cycle. We need it for photosynthesis in plants. So for the oxygen that's in our air. We pretty much need the Sun for absolutely everything. As well as the gravity that it provides, because it's such a large object. It keeps us in its gravity, orbiting around it. The Moon is important because of the gravity that exerts on us as well, controlling the tides. So the Moon plays a big role on Earth as well. Summarize how the outer planets are different from the inner planets. The outer planets are much larger, and the outer planets are made up of gas. They are not rocky like the inner planets are. Our Earth, we talked about the different layers that we have, all rocky layers made of these solid minerals. Jupiter, Saturn, Uranus, and Neptune are all gas giants. They're made of gases.